This is Inspiring Design, where unique innovators come together to share their knowledge, share their insight, and keep us up to date with the latest industry trends. And here's your host, Roshan Senanayake.
What's up, listeners? Welcome to Inspiring Design with yours truly. This is where the best of the best brands, experts, change makers, and thought leaders come together to share their valuable insights, experience, and knowledge. Our goal here is to be the missing link between education, design, and the industry. And today we have a very special guest to speak about artificial intelligence within the construction industry. So let's welcome Alex Ferguson. And I'll give you a little bit of background on Alex. He's a degree qualified aerospace engineer with an executive MBA from the Australian Graduate School of Management. He's passionate about technology and enjoys using and helping people and organizations implement business improving solutions. As a registered project manager, he has experience across a broad range of infrastructure, buildings, and mission-critical systems with experience delivering data intelligence, including machine learning and artificial intelligence solutions for SMEs. He's worked in the Queen's Wharf projects, the biggest projects that's going around at the moment, as a part of the state development, and is simply a wealth of knowledge. So Alex, welcome to Inspiring Design.
Thanks for having me.
Can we start off with a little bit of background on yourself?
Yeah, I mean, you've introduced me quite well there. I went to aerospace engineering, sort of studied that at University of Queensland quite some time ago. And at the same time, I studied a bachelor's degree in Chinese and spent pretty much most of my career working in civil infrastructure, buildings, mission critical data centers, that sort of space, and spent about 5 to 7 years overseas working in Asia in those different market verticals. Probably interestingly, over the last 5 to 10 years, you'll have seen a significant trend towards a more digital approach to engineering, architecture, and construction, looking at how we can leverage information to make better decisions. And so I kind of pivoted my career some time ago into that particular space around sort of being able to perform data analytics, machine learning, generative design, using sort of more advanced algorithms for trying to get better outcomes in a shorter amount of time.
Yeah.
And that's led to me being sort of leading a digital innovation hub for an engineering firm in Singapore, and more recently joining a digital advisory firm where we're building products that sort of target those different markets.
Yeah. And I think this is why you're the right man for the job. When I was sitting in one of your presentations a few months back, and you mentioned some incredible things on how all these digital technologies are going to transform the environment that we know in the construction industry. So on that note, how do you define AI? Like, what is it? Just off the top at a high level before we go into the construction industry, what is AI?
Yeah, interesting question. So I think you can get a lot of different definitions depending on who you talk to. Mm-hmm. But generally speaking, AI in principle is a piece of computer software or an algorithm whose purpose really is to replace the decision making that an ordinary human being would ordinarily perform. Mm-hmm. Things that you've learned over time how to, for instance, recognize a cat or a dog by what you're looking at, because you've seen thousands and thousands of images of the cats and dogs in all different variations throughout your life as you're growing up.
Yeah.
You've been able to recognize those animals, and similarly, what's a chair and a table and that sort of thing. So when we talk about AI in the context of vision, it's really not just these days about being able to categorize what something is in a photo or even in a video. but also identifying the parts of that video that correspond to a specific type of entity, whether it's a cat or a dog or a table or a car or whatever. So AI essentially is trying to replace that human sort of recognition capability there in the computer vision. And the same things are happening in voice too. So for instance, being able to detect what you're in, the tone of your voice. Are you happy or sad just based on the tone? Ordinarily humans can get pretty adept at understanding that someone's angry at me because they're shouting, or someone's unhappy, because they have, a certain tone to their voice. And then, progressing also in that voice space is about being able to recognize exactly what people are saying and converting that into an intent, like understanding from the words that are spoken, what does that person actually mean? And therefore, off the back of that, being able to build some software that could respond to that in one way or another. So AI is just a little bit, you would say more advanced from traditional data analytics. It's, and it's beyond, it's in the realm of data science where you're applying, a large volume of information collected as a resource that is used to train an AI. And what's really interesting is that, the more data that you gather about something, potentially the better an AI you can create. Also, the more computing power you need in order to take all of that data and crunch it and learn from that. And an AI is quite interesting because it learns the same way that we learn, in the sense of, maybe not exactly the same way, but you feed it enough information for it to start to learn, that what decisions and how to make those decisions based on the data that's provided to it. So you do a lot of training. You think about your life. You spend a large portion of your life, pre 2 or 3 years old, learning about the world around you without actually even saying anything. And then one day you start actually talking. And so AI is really kind of in that early stages of your development as a human development, recognizing the world around it through the data that's provided, and then being able to make some decisions from that, sort of like I've already said.
No, and while you were speaking, actually, because we get a lot of teachers and students listening on this, what the image that formed in my mind was from the second Avengers movie, Ultron. I'm not sure if you've seen that. And
I have, yeah.
They have that Jarvis when he becomes a globe, and the holographic version of what Jarvis looked like and what Ultron looked like. It's almost, that's what painted in my mind while you were talking there. And it's kind of scary that we're headed towards what was once fiction. It's coming and becoming a reality now. And
what's interesting, you picked that particular movie because I was sitting in a video conference about 4 or 5 years ago with a good colleague of mine down in Melbourne, and we were talking about Jarvis, and we're talking about particularly a scene in the movie where Robert Downey Jr. is asking Jarvis to do some ordinary task.
Is this when he's prototyping the first Iron Man suit?
I think it was more the one where he was actually reviewing the plans that his dad had created for
Iron Man 2.
Yeah.
Yes. Yeah.
And part of that scene, he's there sort of telling Jarvis, remove this and remove this, and sort of stripping that design that his father had down into its bare raw ingredients and parts, and then was able to realize that this is a design for a new sort of power source, right? Well, it was in that particular video we were talking about, all of the things that were actually happening in that video. So we had Robert Downey Jr., Iron Man, Tony Stark saying to Jarvis, remove X, Y, Z. And Jarvis then had to interpret that and into an actual intent, understand the objects that were involved in that intent, and then perform some actions based on that. And as we went through it, I said to my colleague, look, actually, we can do that right now. Like, we can build Jarvis for engineering. And in fact, over the next few weeks, I said to my wife, could you buy me an Alexa for my birthday so that I can actually just go and program. I'm going to teach myself how to program Alexa
Yeah.
to understand my intent
Yeah.
as a starting point. And then I have another piece of software that plugs into, Revit, which is a 3D design tool for buildings and construction, and that can actually control that platform. So now I can connect my Alexa to my to Dynamo, this software, which connects to Revit, which
Wow.
then leads to that. And it's like, well, why would we do that? Might be because in the future we're going to move away from using desktops and screens to design things and into the virtual world where we can sculpt not just sculptures but buildings and infrastructure in 3D in that environment. And it makes sense to us because we're used to using our hands, right? So we need to have all of those different pieces in place to be able to do that. And we've got the VR technology today, and in the space of a month or so we put up a proof of concept, and it was quite a really interesting project actually. Yeah.
And that's the important thing. Like I think a software like Revit or ArchiCAD or any of these CAD and BIM programs, they're becoming so complex. And it's almost a 10-year, 15-year learning curve to get very proficient at it to be able to run a project or be a BIM manager.
Oh, exactly.
And so students almost, if they don't have the exposure to this in high schools, it's going to be almost like they're 5 years behind when it comes to their colleagues who had that exposure at school. Now, if you can talk to it through an AI system, then that complexity almost doesn't matter.
Yeah.
It's you're utilizing that through your design intent. So I love that. And actually, the more and more the complex the program becomes, there's a point of no return where we can't actually learn all of it. We need to be able to use it as a tool. And I love the fact that you use Alexa for that. That's pretty cool.
Yeah,
that's pretty
and
cool.
natural language processing, which is what the technology behind Alexa.
Yeah.
That's going to fundamentally change how we interact with technology. You think the way Siri has already started to do that, OK Google and all those other sort of Alexas and so on are sort of filling that gap. And I'd even go so far as to say that the platforms that we use today in terms of the design tools we use, they're going to be extremely different in 5 or 10 years' time.
Yeah.
So it's not so much, and there is a significant amount of training required to use those platforms. But in addition to that, I think where the future will go, particularly with AI, is knowing how to use those more advanced tools to get what you want, and do it in a quicker way.
Yeah.
And particularly if you're doing anything that's kind of repetitive, a lot of the time you see in the industry today, people just being the person who sits there and pumps out exactly the same design over and over again.
Yeah.
We're going to shift away from that to an environment where people are more setting the rules for design and engaging with the client and understanding the client needs and translating that into here are constraints that sort of define how the AI might go about doing a particular task.
Yeah.
So it's that sort of top-down, algorithmic type sort of thinking that is really going to lead the industry.
Yeah. And I think that's what leads me to the next question as well, because this is what got me thinking when sitting in your presentation was how are these roles going to change? Now, we've already kind of touched base on, Revit and what this looks like in the future. What do you think within the AEC, the construction industry, what it's going to look like in the next 5, 10, 20 years, how we run projects, what we do? At a high level, before we go into the details of what each role and how they're going to evolve, at a high level, how do you think this is going to change the industry?
Yeah, it's interesting because when we talk about AI, you quite often hear people saying, "Oh, it's going to decimate jobs." Right? Let's be upfront. Right?
Yeah.
That's what. There's this immediate reaction to automation of any kind in industry, and that fear of automation goes all the way back to when the production lines were being set up for cars, and when the typeset machines were being thrown out of the press offices so that they could start using typewriters and so forth.
Yeah.
But what's interesting is that at every step of those, that in our evolution, it's created different jobs.
Absolutely.
Right.
Yeah.
And not less, but typically more than previously we had. They're just in different areas and different capabilities.
Yeah.
what I can't stress enough to people who are sitting in engineering today and learning about different software packages, or learning how to do things in one way or another, is that the way that they're doing it right now is going to change.
Yeah.
Yeah. Some things that I think will take longer to be replaced will be the human interactions, the design thinking, the approach to how you have empathy with clients. So less the technical aspects, because the technical aspects are going to continue to change.
Yeah.
But more of sort of the emotional aspects of managing projects, managing people, managing outcomes. So those client-facing roles will continue to have significant importance, particularly going forward.
Yeah.
But where I see in the technical space things changing is that, right now you have a lot of large engineering firms, and they've become large through mergers and acquisitions, for example, where you have a vast pool of resources that you can throw at projects, and those resources, those people, are very specialist in their capabilities. Over the next 5 to 20 years, those capabilities are going to end up being replaced by computers in one way or another, and we see that with lawyers right now. When you graduated law, 5 years ago, the next step you would go and do your article clerks, right? But now you've got IBM Watson, who can go and search through all of the different articles and find the relevant, case law that relates to your particular case for you. So, asking a graduate to go and do that seems a bit of a waste of time, right? So now what are we going to get those people to do, right? They've got to do something else if they want to. And so now, the next level would be, okay, teaching students how to use IBM Watson, how to program IBM Watson to go and get the resources and to build off of that, to build new products and services that sort of leverage off that. And I actually, that particular example, I had a conversation with my wife, about this particular topic over the weekend. I was saying, maybe in the end, there's no lawyers. Maybe in the end, the algorithms know all of the prior case law, and they can just argue amongst themselves about which one's right. And so no more judges, no more lawyers. I mean, sorry if you're a lawyer, maybe that's going to happen. Maybe it's not. We could be 50 years away from that. But the same goes to accounting, and the same goes to engineering. Is that those things that are, if you think about engineering as a prime example for automation, is the fact that a lot of what engineers do today is standardized through Australian standards, Australian and New Zealand standards, that dictate, what are the allowable ranges for your design constraints. So once you know what the constraints are, algorithms get very, very good at repetitiously churning out various options and finding the best one. Yeah.
No, that's the interesting thing, and even what you meant about the whole empathy side of things, and those roles going to be playing a pivotal role in how we work. It's interesting because even in that movie scenario, going back to Iron Man and Avengers, he still uses Jarvis to perform almost every one of the tasks back home or in his office, but he never actually allows Jarvis to go and interact with the other people, with the other third parties, whether the villains or their team members. It's literally carrying out tasks that you would otherwise spend hours and hours doing. So it's I think what you're saying is absolutely spot on. Now, if we may actually go into how this changes within a specific role. So if we're looking at the designer, say the architect, the building designer, the industrial designer, or any other type, how do you see this changing the way they work? Because I know that in your presentation where I heard you speak, you mentioned the algorithm that already exists, the algorithm that spits out 20,000 code-compliant designs. Can you elaborate a little bit on that, just on how the designer's role will change?
Yeah, I mean, maybe to give you an example of a real algorithm that I developed back in my previous business, was around airfield ground lighting for airports. And in that particular example, ordinarily, what would happen is you would have a designer who's responsible for the horizontal and vertical alignments that are setting out an airfield. Where does the runway go? Where does the taxiway start? Where do you turn off the runway? And the design of all of that is by a bunch of civil engineers who have specialties in that space, and they understand, what are the rules around particular different classes of runways and so forth. So that job happens before an airfield ground lighting specialist comes in and starts setting out all their lighting, because they need to know, where's the runway before they can say where the lights are going to be, right?
Yeah.
And to be honest, that particular activity is very, very rigorously sort of constrained by a standard called MOS 139. And because we know all the rules, for example, the spacing between the lights and how far apart they, how far off the runway center line they need to be, and sort of for different types of runway and different types of taxiways, we can apply an algorithm that would just, take the output from the original civil engineers who did the layout, and just feed that into our algorithm, and it just automatically produces where all the lights need to be, code compliant, right?
Yeah.
So that's a job that today would take a human 2 to 3 weeks, depending on the scale of the problem.
Yeah.
Maybe even a week for a smaller airport to set that out. And then at the end of it, you'll ask them the question, well, how many lights are there? So we'll have to go back and actually count all of the thousands of lights that we've just placed over the last few.
Yeah.
And it seems humorous in retrospect when you're kind of listening to how this works, but that is actually how it works. And so a graduate will be sitting there looking at the drawings, counting, and once you get past 100, the likelihood that you've got some errors is already probably not even 100. The first 20, that graduate is bored out of their brain. Right?
Yep.
So errors galore. Yeah. And then, possibly double counting, undercounting, and so forth. So having written that algorithm, that job that takes 2 to 3 weeks is done in 30 seconds.
Oh, Jesus.
It's not just done in 30 seconds. The number of lights, the location, the rotation, the placement, the vertical elevation, the 3D model placed in the right place, everything all done. So we're talking about moving from a situation where you've got weeks of work just to place the lights, and to 30 seconds to place the lights, count them all, produce all the schedules, produce all the drawings, output everything, full detailed design in 30 seconds to a minute, right? So what does the engineer do now?
Yep.
Is your next question. Right?
Yeah.
What does that person do? Well, that person has to retrain to be able to drive the tool that's created, drive the algorithm, modify it when the standards change, right? It's not about, letting it run and leaving it, verify the outputs, right? So what we really need is, and there will be a transition from pure engineering, math and sort of physics-based engineering, into, okay, now we need a hybrid capability, which is not just pure engineering, but also a degree of sort of aptitude in software development, right? And transitioning to that point where you not only just know how to do the engineering analysis, you also know how to write the code to go and automate the next step. And things will change, so you're going to have to continually evolve that solution over time.
Yeah. No, that's awesome. It's really cool and really scary at the same time. And I'm sure there's students that are listening. They're going to be entering the industry in the next 3 years. It's almost going to feel like what they've learned to date is redundant, which is a scary thought. And if you're in the industry already, then not knowing anything about this stuff, then it also makes them even more worried. And this is the reality that we're in right now.
Well, actually, I'd say what you learn in university, like the first principles that you learn in university, will never be redundant.
Yeah. It's the thinking behind the application.
The application of that into software. So when you go out of when you leave university and enter the real world, right? And it's you start training in all of these different products.
Yeah.
And those products are meant to be doing what you've learnt from first principles how to do and within about 2 to 3 years, you've forgotten first principles. A lot of that. And now you've got a couple of back of the envelope calculations, and we've got some software that does the heavy lifting, right? Because problems that we face today are much greater and more difficult than what you're going to find at a university course.
Yeah.
Even if it's an applied course, right? But those first principles are what let you innovate. It's being able to go back to first principles and saying, actually, if only I could create a stress matrix so I can figure out what all the stresses are going to be in this building, right? Well, I can go and use some software to do that, but that software is limited in its capability. It can only do one job, but I need it to do that plus something else. So I've got to strip that back to first principles and then go and build a new solution.
Yeah.
And that's where I think firms and individuals who are stuck in their ways are going to find it increasingly more difficult in the next 10 to 20 years to be stuck in their way.
Yeah.
And the continuous professional development and education, lifetime education and learning is going to be critical to anyone who's working in that business.
And I think the beauty of what you're saying isn't just even in the AEC, it's actually applicable to anyone, because we're talking about transferable skills here. Totally. So I love that, and the fact that if university students or even high school students can recognize the value that they're getting, the thinking, the first principle, foundational knowledge, and then move on to whatever that application might be, whatever the industry. And this is actually very similar to the questions I get asked going, hey, you're in education and consulting, but you were an architect. Don't you feel like the university career was a waste? Absolutely not. And I tell them that every single time. It's the actual thinking behind it that allows me to apply it into this industry. So that's I love that.
Well, now, I did aerospace engineering. Yeah. And have never applied that into my day-to-day job.
There you go.
In my my side hustle, there's a little bit of that going on, but in the day-to-day, there's no direct application to the aerospace industry.
Yeah.
But the principles and everything that I learned through those courses, how to code, how to break problems down into pieces and solve each problem piece by piece, that is what's going to be relevant in the next 5 to 10 years still.
Yeah. And it's that critical problem solving skill that's been one of the most sought after skills at the moment. And we were having this conversation with CSIRO, and one of their mechatronics engineers who knows how to problem solve is one of their highest paid employees, simply because he knows exactly what to do, what you just outlined, break up a big problem into small bits and just solve them. Even though he doesn't know how to, he'll find a way, he'll innovate, he'll strip it back down to the base principles. So I love that. Now, how do you think, you've touched base on how the designer's role and the engineer's role changes. What do you think about the project manager and the builder? How do you think their roles will be in the next 5, 10, 20 years?
Yeah, it's interesting. The builder and the project manager, in the next 5 to 10 years, I think they need to become a lot more technology savvy. As a project manager, information is what you need day in, day out. You live by the information that comes in to make decisions about how to best manage the project, whether it's about risk or cost, whether it's about people or schedule, all those different aspects of project management all rely on external information. In the course of a construction project, there is an inordinate amount of information that is generated through a project. In more traditional delivery approaches, a lot of that is paper-based. Even today, it still is. Sign-on registers still, everyone's taking a pen, signing their name in the morning to check in on a site, for example.
Yeah.
But as we move into the next era of construction, and it becomes more important that project managers are not reliant on specifically, individuals to be able to give them the solution that, that individual can do, but to more set the strategy for how do we manage information on a project? How do I make sure that the time it takes for that information to flow from wherever it came from to me is as short as possible, as automated as possible, and how do I have the right analytics in place to actually make the right decisions when that information comes to me. And so, when you talk about things like health and safety reporting, for example, it's too late a month later to be providing reports about HSE issues. They need to be real time, happening as they happen, right? And so it's really about project managers and construction managers and anyone who's in that managerial role who is making decisions about setting the strategy early as to the information that they need to do their jobs right. But not just that, looking further into the future, because if we talk specifically about AEC, right, the vast majority of the costs associated with an asset is not during design or construction. It's during the ownership and maintenance of that asset. More than 80% of the costs of the lifetime costs of an asset is in operations and maintenance. So these are the people who are going to be handed over this thing that's now built or done or whatever, and they're going to have to maintain that going forward. Quite often what you see in today where you've got a BIM strategy in place is that we're trying to bring that those requirements, those information requirements, forward into the design and construction process so we can capture the right information at the right time for them to be able to do their job, but at the same time, here's some complexity, also having the right information for the construction manager to do their job or the design manager to do their job. And it's quite interesting because I think that we're not there yet in terms of the technical literacy for project managers in Australia. We certainly have a long way to go to ensure that people understand what the platforms can do today and how they're relevant to your decision making. Yeah.
No, absolutely. And I think this exactly brings me to that next question: is how can professionals right now, what can they do? What advice do you have for them to respond to this, to evolve, to change? And I feel like you've already kind of touched base on it, and I think this needs to be coming with a mindset change, a huge mindset change. But in your opinion, what do professionals right now, what can they do?
I mean, the primary thing that anyone can do really is educate yourself. Right. Become less reliant on others. Read a significant amount about technology in your particular industry. It's really interesting that disruption for the banking industry, as an example, hasn't been coming from the banking industry. It's coming from the tech industry, right? So if you're one of the big four in Australia, your concern isn't the other three. It's a little small fintech company that started up that's taking a small bite out of your lunch, and the thousands of them that are actually joining in, right? So it's death by 1,000 cuts, right? If you're in the AEC industry, you haven't felt that yet, but it's coming, and it's coming pretty quickly. Like, we already see small businesses starting up in Brisbane and Sydney that I know of that are just pumping out, like, they have algorithms, they'll just pump out an automated design in minutes, right? And now we're not talking about, we're shifting the conversation from labor as a key metric, the billability and chargeability, to outcomes-based sort of models for a business. So for people who are in there and in the middle of all of that, I think the first thing to do is recognize there is risk and opportunity right now for you, and it will continue to occur. The risk is you do nothing, and the opportunity is that there's a lot of opportunity in this space to disrupt other people, right? So be the disruptor, right? Go and learn, go online and take a course on Python and learn how to do a little bit of basic coding. Even if you're not going to code up, the next,
You understand the
solution.
potential.
But you at least understand where people are coming from. The other thing that, so software development capability will be important. Understanding how that works. Understanding databases, understanding how data moves and flows between different platforms, very critical too. And then even more if you're into it, jumping into just learning a bit about AI, learning how to write an image classifier, or how to reuse something that someone else has already done. And there's a lot on GitHub, for example. You can just download projects that people have already done and run through tutorials and see how you can apply machine learning to your problem, or an auto regression model, or other ways of kind of predicting the future, for example, for whatever you're doing.
No, I love that. And what do you think the universities and schools can do, looking at, because they're the sectors that are going to be molding the job force that enters in the next 5, 10, 20 years. Do you have advice for them on how they can prepare for this?
Yeah, I think I'd say that first and foremost, make it fun.
Yeah. Make
it fun. If people aren't entertained while they're learning, it's incredibly difficult. Mm-hmm. As an adult, and you have and wanting to learn about anything, right? You have lots of different platforms online where you can go and sort of teach yourself, whether it's brilliant.org or I'm not, and I don't have any shares in any other companies, just but examples of where you can continue education, right?
Yeah.
And then as an adult, you get to choose the ones that resonate with you, because you choose with your money, right?
True.
Children and university students and whatnot, they don't have a choice. They get the curriculum that's put forward to them. So, they have extracurricular learning, but when they're in the classroom, that needs to be STEM needs to be fun. Those courses, and I'd say this also. Me as a man sitting here with a 12-month-old daughter who is incredibly inquisitive, we also need to spend a lot more time getting it right for the young women who are coming through high school and learning about STEM, and that it is a valid career.
Oh, absolutely. Right? Yeah.
But also, I think what's really interesting about STEM is that you don't actually have to go into a career in STEM to be interested in it, right? You can still enter an entirely creative career, but having that sort of framework, that scientific method, that knowledge of how to break down problems, is just going to improve your life so much.
Yeah.
Be able, whether it's should I take out this loan, and what's the financial impact to me and my family if I take out a loan, versus what's the best color to paint this picture in.
Yeah. And I think that's brilliantly said, because STEM skills, I'm in consulting and education and training, but STEM skills are still valid and they're still part of the way we do things. So absolutely, 100% agree. And I think the fact that your daughter is seen as in that point of view, she's really lucky, because women are more and more coming into STEM related jobs, unlike the last 5-10 years. So it's actually shifting a lot more in that scenario as well. So she's very lucky. She's very lucky to have you as a father.
Well, and it's not just that. I think we've got the whole sort of gender equality thing with a particular lens, and we're looking through it with a particular lens. I think just as important as it is for us to say that we should promote STEM to women, we should equally be promoting alternative careers to men, right? It's not, and I would say it doesn't matter what career you take, having a grounding in the principles that sort of underlie the scientific methods that you see in STEM and in math and so forth, that I think is relevant to everyone, right? But I think the more and more as we sort of move on into, I'll go back to my first point about empathy, right? As AI starts to take on more and more of the things that we do throughout our day, what will we be left with is our humanity, and it is through empathy for others and through wanting to take care of and educate and assist others that will truly get value in our lives beyond what we do, from 9 to 5 or 9 to 6 or whatever your working hours might be. So it's not just enough for us to promote STEM to women, but it's also to promote early childcare to men and primary school education to men, because the students there, as I said, like, it needs to be fun, but also they need role models that aren't just that aren't also biased to one gender or another.
Yeah.
And that gives them opportunities to see how life, gives them role models, I guess, to look up to in the future as well.
Yeah. No, well, beautifully said, man. And I think that I always like to end my episodes with advice for students and graduates, because I do get a lot of students at that tertiary level who's going to be in the industry in the next 1 to 5 years. What's your advice for them in terms of, artificial intelligence and how they can prepare themselves to be that disruptor?
Try everything. Spend 30 hours doing a Python course online, even though it's not part of your course curriculum, right? It doesn't matter how old you are. Just try it. Don't just read about it too. Do it.
Learn through play. And then teach someone else, right? I can't remember where the quote came from, but the best way to learn is to teach others. Absolutely.
Right? And in doing so, you quickly find where all the gaps are in your knowledge, and then you're more likely to be inspired to go and fill those gaps too. So for young people who are listening, definitely, just whatever you're passionate about. Just try other things too. Don't just focus on I love when I was younger I loved painting or actually pencil art, but as I grew up, that kind of transitioned into technical drawing, and that then transitioned into engineering, right? So for me, actually, that passion for drawing translated directly into a future career, right? But it was an evolution. But I tried painting. I hated painting. I just tried everything. Right. I did art at school, but I felt it was just too subjective. I personally needed structure, and hence technical drawing takes the win. So for anyone who's listening, absolutely try different things, because if you are afraid of trying new things, then unfortunately you're just going to get overtaken by people who aren't afraid. And you're going to fail, but that's okay. You're young.
Fail forward.
I won't say how old I am, but anyway, I'm old enough to know that I still have a lot of failures left ahead of me, and I'm happy for that.
Absolutely. Mate, beautifully said, and thank you so much for giving up your time. And I know I've taken personally away a lot from this conversation that's going to influence how I train teachers and students. So that's brilliant. So thank you so much.
Thank you for having me.
That's it for today, folks. So if you haven't already been inspired enough for yourselves, jump on to rashansenanaika.com/podcast and check out the show notes from today. Make sure to follow what Alex is doing, connect with him on LinkedIn, and follow him on Twitter and Instagram on his name @BetterForToday. So it's been an amazing journey having a chat with Alex here. So deep dive into what he's doing and learn through play. Lastly, before I leave, make sure to click subscribe and share your thoughts. And I'd love to hear your feedbacks on today's episode as well. And if you're really brave, you can share your love and share a review. So thanks so much. Till next time.